In this video, we're going to learn about the content in Lesson 3.7, which is on even and odd functions. We'll be able to tell graphically if a function's even, odd, or neither of them. We'll be able to tell algebraically if we plug in a number, and in algebra in general. We'll also note the difference between being even or odd degree versus being an even or odd function. If a function is even, we say it is symmetric about the y-axis. That basically means if you would fold down a y-axis, the function would lay on itself. With numbers, if we would substitute a number, let's say on this graph we plug in the number 1. When we plug in 1 here, x is 1, we get -3. It actually is the same as if you plug in the opposite of 1, which is -1. That would be -1 gives you a y value of -3. In general, we would say that means if you ever plug in an x value, it should match what you get when you plug in the opposite of that x value. For a function to be odd, it is symmetric about the origin. Now what that means is it actually is kind of like a 180 degree, if you will, or I like to think of it as reflecting over the x and the y-axis. Could think of it as if you had a line down the middle here, it would flip over that, kind of a diagonal line. Let's try it with numbers. If I were to plug in, I'm going to write this a little backwards. If I were to plug in 1, so if I plug in 1, I get 1 up here, 1, 1. Now, if I were to plug in -1, I get -1. That's down here. So if I plug in 1, I get -1, I get -1. Again, they're kind of like that opposite. So it's not true that f of 1 equals f of -1. It's that I would need a negative sign here. Because remember, when I plugged in 1, I got a +1. So I need to throw that negative out here so it matches. Because when I plug in -1, I actually get -1 as my y value. We would say this then. F of -x equals -f of x. I also like to think of it as kind of the opposite. So again, when we plugged in 1, we got 1. When we plugged in -1, we got -1. So sometimes this notation is a little bit off, but they should definitely be that opposite from each other. When you plug in 2, you might get 8. When you plug in -2, you get -8. Now, when it's neither, it just means that it doesn't fit one of these first two conditions. So we would say f of x does not equal f of -x, nor does f of -x equal -f of x. So that just can't happen, and you can see this graph does not fold over the y-axis, nor does it fold over like a diagonal line and have opposite values. Let's look at some graphs here for an example. Here we have, is this even, odd, or neither? We can use the graphic way to do it. This goes 1, 1. This is -1, -1. That would be odd, because you can also see that it would fold over this line, and plugging in a +1 brings +1, plugging in a -1 brings -1. Here we have an even function because it would be symmetric over the y-axis, and that's all you have to indicate. Here we have neither because you couldn't fold it down the y-axis or down this line y equals -x. Now with equations, using more of an algebraic approach, I might try plugging in 1 to this equation. That would mean 4 times 1 to the 4th plus 5. That gives me 9. When I plug in -1, let's see what our answer, remember, this would be like -1 times -1 times -1 times -1. That's going to be a +1 times 4, and that's still going to give 9. Because these came out the same, it means my function is even. Where over here, let's say I plug in 1 to this equation, I would get 5. But if I plug in -1, 1's usually pretty easy to plug in. -1's where you gotta watch those powers and multiplying by negatives. This would give me -2 minus 3, which equals -5. Because these are opposites, it's going to be odd. Now, these are how to determine if a function is even or odd. Remember, we used to talk about the degree of a function being even or odd. So one question might be, does an even degree function, so like x squared plus 5, x minus 3 squared or minus 3, does an even function have to be even degreed or vice versa? These are all even degree functions because they all have the squared. Let's look at their graphs. The red one, it does fold over the y-axis. The blue one, it does fold over the y-axis. The green one, however, does not. So no, just because it's an even degree does not mean it's going to be an even function. Same thing with the odd here. My odd degree functions of 3, this first graph seems to be flipping over that little line like a nice little diagonal because that's the black one. That x cubed is odd. But when I shift it, think of like a transformation of moving it to the right too. It no longer folds down this line. It does not go up and then over the x-axis or the x and y-axis. So just because a degree is even or odd, or the power is, does not tell you if the function's even or odd.